Okay, this is U7L5 um, with square root and cube root functions. Our objectives today are going to be graph square root and cube root functions using transformations. Okay, so let's look at the parent function for a square root function. Okay, so a square root function looks like this. F of x is equal to square root of x. And like with any new function that you haven't dealt with, we are going to use a table of values, right? I have my x and my f of x in here, and I'm going to pick some values, see where they land, and see if I can sketch this. Okay, this is just the parent function, meaning I have I have the most basic form of that function. Nothing else is being introduced into the function. Okay, so I know that f of x is the square root of x, right? So I'm going to pick some numbers that are easy to do, like 0, right? You always start with 0. What is the square root of 0? 0, right? So that's nice and easy. Let's try 1. Oh, by the way, 0, 0. I'm going to plot that as I go along. It's right there. And then 1, square root of 1 is 1. Easy enough. It's right there on the graph. And then I'm going to do square root of 2, right? So x is 2. Square root of 2 is going to be something really hard, right? Because 2 is not a perfect square. So when you pick these values, you want to be smart with what you pick. I am definitely not going to use 2 for x because I can't do square root of 2. So what should I use for x next? Should I use 3 and then find square root of 3? No, right? I'm hoping that all you guys would say, oh, now we should use 4, right? Because the square root of 4 is 2. All right, so that gives me a whole number. Nice. The next one should be 9. Square root of 9 is 3. So those are my values on my graph. Okay. So it makes kind of like a curve here on the graph. All right. That's the shape of it. Now, should I go to the negative side, right? If I pick negative 1 and find square root of negative 1, that gives me I. It's an imaginary number. Remember, this plane that we're working with is a real plane. All the numbers are real, so we don't have I on here. So we can't graph this, right? This is not part of the domain. Okay, this is not part of the domain. So we don't do negatives. Okay, so that's one of the most important things about square root graphs is remember that your domain includes only the positive values under the square root. Okay, so the graph on the left side, there's nothing, right? Nothing on the negative side for x. Now we're going to sketch that graph and it looks like this, right? That's a nice curve, nice and smooth curve. Okay, remember if you picked 2 earlier, it would have given you some kind of decimal number, right? The problem is we don't know exactly what that decimal is, so we can only estimate it. But it's somewhere here, right? That's the curve. That's the parent function for the square root. Now we go on to dealing with transformations. So there are 3 numbers that we add into the function itself, and that's a, negative h, and k. We've dealt with this before. You guys know what they do, but let's repeat. Let's go over this again. So a, or actually you start with h. Negative h is the horizontal translation, which means you move left and right, right? So what you do is you add that h or negative h to your x values. So what it does is it moves your function left or right, right? The next one would be a. Remember, this is it's important that you do this in order. Okay, otherwise it's going to mess up your graph. Okay, the next one you do is a, and a is the vertical stretch and shrink, and also the reflection. Right. What you do is you multiply your y values by a. Okay, that's what it does. Right. It kind of stretch it out or shrink it. Okay. And then k is the vertical translation, which is to move it down or up. Okay. Now let's do an example with all of that. Example 1, I have f of x is equal to 2 square root of x under the square root. Okay. Remember, there's a distinction between h and k. Is that h is under the square root and k is outside. So in this problem, we have 3 under the square root, and there's no k. So k is basically 0. Okay, the step number 1, we want to plot the parent function. And the parent function, these are the values you want to basically memorize, right? 0, 0, 1, 1, 4, 2, and 9, 3. It should make sense to you why these numbers are the ones that we have, right? Because square root of these numbers are these numbers, right? Square root of all the x are the y's. Okay, the step number 2 is we're going to do with the h first. right? Under the square root, that's the number you go first in order. So you add -3 to the x values. So what it looks like is that everything is going to shift to the left 3 units. Okay, so I'm going to take the same table and then so what I'm going to do is I'm going to get the y value. We get the functions for when it's x plus 3. And what it does is I add -3 to my x values, right? So all the y values stay the same. Okay, I'm not doing anything to the y values, but I add -3 to my x values. So 0 plus -3 is -3. 1 plus -3, or subtract 3, is -2. 4 minus 3 is 1. 9 minus 3 is 6. So remember, this is a positive 3. That's why I'm subtracting 3, okay, to the x values. And of course, with the new values, all my points shift to the left 3. And these are my new points, okay? And then the next thing I do is I want to multiply the y values by 2 because of that 2 in front, okay? And what it does is the vertical stretch of a factor of 2. And my x values stay the same this time, right? Nothing's going to change. All these x values stay the same. The y value is going to multiply by 2. So 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. And 3 times 2 is 6. And what that does is all the values go twice as far away from the x-axis, right? You see, this one is on it, so it doesn't go anywhere. But these move twice as far away, okay? And there you go. Those are my new points. I make a sketch, and there's my graph. Now let's talk about the domain and range of this function, okay? Domain starts at -3 and goes to the right? So domain is anything, x is anything larger than -3, and the range is from 0 and up. So anything large, y is larger than or equal to 0. Example number 2, I have f of x is equal to -3 square root of x plus 4. So number 1, again, step 1 is to plot the parent function with those same points, right? You got to memorize these points. Step number 2, I multiply the y values by -3, which is a vertical stretch of a factor of 3 and a reflection across the x-axis. Okay, this is important. It's negative, so there are two things that it does. It stretches and it reflects. Okay, and I do this before the 4 because the 4 goes last. The 4 is outside the radical sign, whereas earlier the 3 was under the radical. Okay, so you do the number under the radical first, and the number in front multiply to it, and the number added in the back last. Okay, so what I do is I multiply the y values by -3. So all my x values stay the same, and the y values multiplied by -3, multiplied by -3. All those values multiplied by -3, and I get these values like 0, -3, -6, and 9. So what it does is, see, it stretches it out, right? Earlier it was kind of flat like this. Now it curves more and it goes under instead of going above. Okay, so a reflection and a stretch. And then the next step would be add 4 to all the y values. Okay, that means the shift 4 units up. Again, all the x values stay the same. And then y values, I add 4 to them, right? 0 plus 4, -3 plus 4, -6 plus 4, -9 plus 4. Again, these are the y values from earlier, and I add 4 to all of them. And what that does is it shifts all the points upward 4 units. Okay, now I have my curve. There it is. Domain and range going off of the graph. Domain is x is larger than or equal to 0. And for the range, y is less than or equal to 4. Now we go on to the cube root function. Let's do the parent function with the cube root here. Right, I just picked my x and y, of course. This is a cube root, so what number should I pick? 0 still works, right? Cube root of 0 is 0. There it is. Cube root of 1 is 1. It's there. Cube root of 8 is 2. Now see, this is a cube root. It's different. You don't pick 4. 4 is a perfect square, not a perfect cube. So I pick cube root of 8, which is 2, because 2 times 2 times 2 is 8. Right, you can go on, you can do 27, but that's kind of outside of our graph. It's too big, right? But cube root of 27 is 3. Now you can go to the negative side. Can you do cube root of negative? Right, you could. So that's a big difference there. Cube root of -1 is -1. Oh, there's my point. -1 and -1, that's another point. And then cube root of -8 is -2. Remember, negative times negative times negative gives you a negative, so it's possible to do the cube root of a negative number. Okay, so the big difference between cube root and square root is the cube root, you can have negative under the radical, whereas in square root, you can only have positive. Okay, and then my curve, it looks something like that, right? There's a funky little curve in the middle here, but ignore that. It should be a smooth curve across when you sketch it. Okay, let's do an example. The transformations are exactly the same. Okay, so here's my function. And then number one, plot the parent function. All right, parent function, you guys use the same points, right? So here are my points. I got 0, 0, 1, 1, 8, 2, -1, -1, -8, -2. Right? Try to make sense to yourself. Like, why are these numbers the way they are? Right? Look back at when we did the parent function. Cube root of these numbers. These are perfect cubes that we're using. And then we find cube roots for them. Okay, and there they are. That's a nice smooth curve across. And then step number 2 is I want to shift right 3. Right? That's -3 there. That means I shift right 3. That means I add 3 to all my x values. Right? So all the y values stay the same. X values, I add 3. So I add 3 to all these values, and I get these new points. And what that does to my points is it goes to the right 3. Okay? And then next step is now is a vertical stretch of 2 because the 2 in front. Right? That what that means is I multiply the y by 2. Right? All the x's stay the same. The y's get multiplied by 2. Right? So what that does is it goes twice as far away from the x-axis, right? So this one in the middle stays the same, right? Because 0 times 2 is 0. But this one, 1 times 2 is going to be 2. 2 times 2 is going to be 4. You see how that goes. There you go. Okay? And these are my new points. And the last thing is I got to do the 5 in the back, right? So step 4, shift 5 up. And that means I add 5 to my y values. The y values can get added 5, and x stays the same, of course. So that means that everything moves up 5. There we are. And then you make a sketch. And then for this one, domain and range. Domain and range for a cube root is always going to be all real numbers. Okay, domain and range. For a cube root, always all real numbers.